All right. Welcome to the Tuesday office hour for Unit 1 of the Introduction to Data Science module. As per usual, you can ask questions in the live chat, and I will peruse the message board for questions as well. I had a little peek earlier. I saw there were not that many new questions, but I remember there were some yesterday that I didn't get to. So I'm going to scroll down, and see, have a look at some of these as well, perhaps. All right. So why don't we get started? Point class is working, but grader shows 0 grades. These both look like reasonable add and subtract methods, but their repr method does not conform to the style of the given in the instructions. Additionally, it's important to note that in the repr method, there must be a space between your x and y value, not just 0.3 comma 4, but 0.3 comma space 4. The parentheses around the addition in the add method does not make any difference. You may keep it or get rid of it. It does not matter. All right. Very similar question, similar answer. I'll just give this an upvote. I know I mentioned this a lot. People who come to office hours probably don't need to hear it, but often there are details in the instructions that can make a very big difference in your grade. I suspect this is not formatted quite correctly, or quite as they had planned. So let's reformat this a little bit. This is good advice. They say they're still getting the same output, which should not be the case. I think. Next number equals the previous number, this thing, previous number equals next number, append next number. I'm trying to think if there's any problem here. It seems like this should work as far as I can tell. Not going to spend more time on that one. How many arguments can a function take? Arbitrarily many. You can give, you can define a function to take as many arguments as you want, including an undefined amount of arguments. So I could define a function that takes arguments a, b, c, d, e, f, g, h, i, j, k, l, m, n, o, p. You get the picture, right? I can have as many arguments as I want. It doesn't matter. And if I, have a function that's going to take all these arguments, I should probably do something with all of them. There should be a reason that I have all these arguments. But I can have as many as I want. I could also have, let's see. I create a list containing all these things, and I turn them all into letters. Or strings is what I mean to say. Well, I didn't need to turn it into a list. Right, I could call my func and give it all these arguments. However, you'll never see anything like this. In fact, it's considered bad style for a function to have more than like 6 arguments. You should try and write functions that accept less than 6 arguments. Each argument is like some bit of data that the function needs in order to run or do its job. And usually, if a function requires more than 6 arguments, it's probably trying to fit too much into that individual function. You probably want to break down that function into smaller parts. In a situation like this is like particularly annoying because I have to supply all these arguments. If I supply any less, then the function won't run. 12 required positional arguments. I need all of these. I can also define functions, I said, that take a variable amount of arguments. So I can say, for instance, something like this. And then I could call my func A, B, C, D. And there we go. So I can pass in as many or as few arguments as I want here. And it will work. I've mentioned this star arg syntax that I'm using here in the past. This is the way that we accept variable amounts of arguments to a function. It's not that commonly used, and I would really not go overboard on using it. Usually we want to be explicit rather than implicit. Right? In the Zen of Python, it says explicit is better than implicit. This is not a very explicit way of referring to the arguments of your function. This tells me nothing about what kind of information I expect this function to receive. There are specific use cases for this that make a lot of sense, but they're somewhat more advanced Python techniques that we may or may not cover during this course. Probably not, but long story short, a function can take as many arguments or as few arguments as we want. Yeah, 0 is the least number of arguments a function can be passed. How do we know what's callable and what's not? Well, one way is my favorite way, which is to try it. List, for instance, is callable. Sum is callable. I need to give it an argument, but it is callable. Something like L. Oh, that's callable too. Interesting. If I make a list, my list is not callable. So list object not callable. So you can always try calling something, and if it doesn't work, it's not callable. But that's sort of like maybe not the most useful answer for thinking or knowing in advance when you're writing code. In short, functions tend to be callable. Sometimes classes are callable. Certainly when you're instantiating an object from a class, you make a call to the class to instantiate the object, but classes can additionally be callable beyond that kind of call. But pretty much functions and classes, that's pretty much it. Objects, yeah, may or may not be callable depending on how they're defined. Things that we tend to think of as variables, usually we don't expect to be callable. Data structures, we don't usually expect them to be callable. Integers, floats, that sort of thing, not callable. Functions, definitely callable. Classes, definitely callable for object creation. Objects and classes additionally may be callable beyond that, but it varies from class to class or object to object. A lambda function is callable, just like any other function. A lambda function is a function. It is no different from a regular function. The only difference is that a lambda function does not have a name. Is dir useful in the case, I assume you mean, of like figuring out what's callable? Dir does not tell us what is callable and what is not. Dir will show us all the methods and attributes defined by a type of object, but it does not tell us which are methods and which are attributes. List object has no attribute distance. Are you submitting List object has no attribute distance. Let me check something here. I'm pretty sure I know the answer to this question, but I want to make sure. So my questions in connection with this question are, one, are you submitting the compute result function to the grader, or are you submitting this list? You should be submitting the compute result function to the grader, i.e., as usual, don't change the grader.score cell. Secondly, in your compute result function, are you using point objects and cluster definition for the centers of the clusters? In your compute result function, you should be calculating distances between points and the centers of the clusters. But if you are representing these points as tuples instead of point objects, then there is no distance method to call. I suspect this error is coming from your from somewhere in your solution code rather than from the grader directly. Delete Shift Tab. I don't know this hotkey, but I believe what you're referring to is maybe the same thing as if I do a question mark, question mark. It brings up this little kind of prompt that describes what kind of object I'm working with. This still doesn't necessarily tell us if something is callable or not. Nowhere here does it say that I cannot call this list object. And in fact, it tells me I can call the list class, which may make me think that I could call this list object as well, but it's not the case. Generally, you can usually make an educated guess, simply because like 95% of the time you're calling something, it will probably be a function. And if the thing you're trying to call, or a class, and if the thing you're trying to call is not a function or a class, then it probably won't work, because not many objects are callable other than functions and classes. For blah in range. This is a formatting nightmare. Let's take all of this. And hopefully if we just do this, it still does not look very good. That looks marginally better. Okay, so if point distance A center is less than point distance B center, tuple object has no attribute X per point in points. When you okay, let me check something else again. The very first line of the compute result function should be this thing that we wrote for you, which we gave to you as part of the framework skeleton definition of compute results. That way, when you iterate for point in points, each point should be a point object. If you have removed this line or otherwise turned the objects in your points list into tuples, as your error message suggests, then you cannot call point.distance. In short, your error message suggests that somehow in your compute result function, the name point does not refer to a point object. You would then conclude that your list points in compute result does not contain point objects. So this person is iterating for point in points. They call point.distance, and this raises an error. Tuple object has no attribute X. Ah, no, it's the center, because that must be other. Otherwise, this would say tuple object has no attribute point distance. My mistake. Okay. Since you can successfully call in your cluster definition, the center attribute should be a point object. We can only compute distance between 2 points, self and other. Since the traceback of your error traces to the point.distance method, we know self is correctly a point object. Therefore, it must be that other is a tuple with, and therefore has no attribute x. In your calculation, other refers to the center of the cluster. It does appear to be working down here, though. It's strange that it appears to be working when you test it with A equals cluster 2, 3, and 0.12 dot distance A center. Somewhere, this suggests perhaps somehow your cluster center starts as a point object, but perhaps gets updated to be a tuple. Check your cluster dot update method and make sure it doesn't change center to be a tuple instead of a point. I bet that's what's going on. I bet the update method is changing the center to be a tuple. How to read and write docstrings. Sure. Docstrings come in a great variety of qualities. Some are very easy to read. So we can always view docstrings by taking an object and putting a question mark afterwards. Sometimes docstrings are really straightforward. A pandas data frame is a two-dimensional, size-mutable, potentially heterogeneous tabular data structure with labeled axes, rows and columns. Arithmetic operations, blah, 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 right? Like this is written in a very plain way to understand. It shows us the signature of a call to this class. So we can call this class with a data argument, an index argument, columns argument, dtype argument, etc. And it even defines what these various parameters or arguments are in the docstring. So data, numpy nd array, dictionary, or data frame. Dict can contain series, arrays, constants, or list-like objects. So it tells us all the different kinds of things we could pass in as data. It gives us examples. Some docstrings are like this, and they're super easy to read. Some are more minimal, like with list, this docstring is super short. List, new empty list. List, iterable, new list initialized from iterables items. So that's super short. And it kind of makes sense in that there's not that much to say about list by itself. There's docstrings for the methods. Append object to end of the list. It returns none. Yeah, so sometimes docstrings are very short, and there's simply not that much to say. Sometimes they're a lot more detailed, and often those are a bit easier to read just because they tend to use a lot more words. But the objects they describe might be a lot more complicated, or the functions they describe might be a lot more complicated, which is why they have more detailed docstrings. As far as writing docstrings, we can write a docstring like this. So if I want to define a function, for instance, that count to 10. Oops, didn't mean to do that. I would put a docstring with triple quotes, and I would say counts to 10. Starting from 1. And this is a really short docstring because this function is not going to do much. So I can call this function, but I could also, just like with our list or data frame or anything like that, we can put this question mark here, and we can see the docstring counts to 10 starting from 1. So docstrings go at the start of a function or class definition, and they're enclosed in triple quotes. And if you want to have a multi-line docstring like we saw earlier with the data frame, conventionally you would have a very short one-line docstring followed by more information. This function uses a range object to iterate between the numbers from 1 to 10, printing each to string with each step of the iteration. So that docstring got a little bit longer now. There's a bunch of style conventions about how docstrings should be written. I don't know all of them, but they exist. You can absolutely have a function that calls other functions. I encourage it. We've done it in the past. We do it in the VC mini project. This is a very common thing to do, to have functions call other functions. So in the VC mini project, in our compute result function, we call the distance method of point objects. That distance method is a function. We call the update method. We call the add points method in these parts of compute result. So yeah, it's very common to have functions call other functions. And we can even pass functions as arguments to other functions. And we saw that actually today as well when I was describing the variable number of arguments. This reduce function receives a function as one of its arguments. So that also is a very common pattern in Python. And we'll see that many more times. Actually, we'll see it a lot in the upcoming lectures on pandas. Dict has an update function or an update method, but there's nothing that prevents us from defining an update method in the point or in the cluster class as well. Cluster can have a totally different update method from dict, just like set has a totally different update method from dict. Set also has an update method, but there's no problem with set having an update method and dict having an update method, and those two update methods doing different things. Because they exist in different namespaces. In the VC mini project, the update function that we define exists in the cluster namespace. It exists in the namespace of our cluster class, whereas the update function of dictionaries lives in the dict namespace, the namespace of the dict class. So there's no risk of a conflict here because we always have to be doing like cluster.update or dict, my dict.update. So it's clear from the type of object we're working with what function we're invoking. Yes, sets and dict update methods are different because sets and dicts are different data structures. Sets don't have key value pairs. Dictionaries do. When we use the update method of a dictionary, it has to do some kind of business with key value pairs, which would not be appropriate for a set. So they absolutely have different update methods. You may want to review, there was, during the Pythonic lecture, let me see if I can pull up the timestamp for you. During the Pythonic lecture, I talked a bit about namespacing. And I believe I gave an example about parsing methods. Okay, so it may have been actually in not that video, but the subsequent video. Okay, so I don't know exactly where it is, but I believe somewhere in this video on modules, I talk about this idea of namespaces and how it can be very useful to use hierarchies of names in Python so that we don't have to come up with different ways, different names for functions that do basically the same thing, but with respect to different data structures or different objects. So I'd suggest reviewing that video for more clarity around that idea. After the course, there is no way to reach me. I mean, there's some way to reach me. I will continue to exist. I have an email address. I'm an employee of the Data Incubator. If you go to their website, you can probably find my business email. But I will say after this course, I will be teaching the next cohort of students, and they will require my attention, just as you all have required my attention. And I will probably prioritize their needs over any kind of ongoing communication. The data incubator has a website. They have an about page, our team. Here's everyone that works at the data incubator. There's me. So yeah, I'm out there. You can find me. I exist. All right. Okay, this is a question that's been asked a bunch of times. I'm just going to close it as a duplicate. Actually, something I should advertise, and again, like people who are going to office hours probably don't need this advice necessarily. But if I have a question, for instance, error from grader, and as soon as like I type in a question here, I get all kinds of suggestions for similar questions. So, you know, if I'm going to ask a question, I should read through these and check like, oh, please help. I am keep getting the following error message from the grader. What was that person's problem? Okay, this is not the problem I'm having, but you know, perhaps there are other questions here in that list that have that are more similar. So we should always just check for similar questions. There's also a related questions panel here over on the right if you open up a question. So the message board tries to, not only can you search using this search bar, but also anytime you're writing a question or looking at a question, the message board is trying to suggest to you questions that might be similar. So please take advantage of these features. They're very nicely designed. I noticed in Python, and unlike other object-oriented programming languages, you can reference a number of attributes more than what was defined in the init function inside the class. Yes, it's possible to even create new attributes outside of the init function. Yeah, and it doesn't have, and it can be added to individual objects as well. Yep, exactly as you say. Car1.max speed, model number. Yep, absolutely. The main thing here is that other car objects will not have this attribute. So if I do car2 equals car Mercedes 2007, then car2 dot max speed will give me an attribute error. So those car1 dot max speed is defined at the object level. So any attribute you create for an individual object does not get shared to other objects of that type. This is indeed in contrast to some other object-oriented programming languages, but Python tends to play pretty fast and loose compared to a lot of languages, generally speaking. You know, there's no type safety of any kind. It has this sort of better to ask for forgiveness than permission kind of attitude where like we're encouraged to try accept rather than if then. So it is a peculiarity, but it's also like very typical of Python in a way. Are the word item or items reserved keywords of Python? Let's find out. So that didn't highlight in green when I typed it. And if I add an S, it's also not highlighted in green. So neither item nor items are reserved keywords. Any reserved keyword will show up in green, like list or del or picked, or even the number 1 or 12. Those are also green. So any protected word or combination of symbols, if it shows up green, it's protected. If it doesn't, it's not. It's possible to encounter problems with notebooks failing to load if your notebook gets flooded with output and becomes too large of a file. Jupyter will have a difficult time opening any notebook that is, say, more than a few megabytes large. 10 or more megabytes is already an extremely large Jupyter notebook, and probably indicates that we printed way too much output into the notebook. Unfortunately, there is no simple way to recover a notebook under such circumstances. The method I would suggest is not simple, but is one of the only reasonable options. 1, download your notebook to your, open a new notebook. Import JSON. Import JSON and open the problem notebook as a file in your new notebook. Parse it using the JSON module. So for example, with open path to bad notebook.ipynb r as f notebook equals json.load f. The notebook is now a JSON-like object, i.e. nested lists and dictionaries. In fact, all notebook files are JSON files that are parsed and rendered by the Jupyter Notebook server. We can use this fact to modify a notebook as JSON. The notebook has a cells field containing all the cells of the notebook. Each cell may have an output field. To clear all the output from the notebook, we should do something similar to, but maybe not exactly, for cell in notebook cells, if output in cell output equals nothing. You may need to alter this code slightly. I'm writing this from memory rather than doing it myself. Finally, use the JSON module to save the notebook. And notebook. So I would try something like this. It's certainly not simple, and it may take a lot of independent thinking and problem solving, but this is generally how I fix this problem if I accidentally print out a huge amount of output into a notebook. Is the syntax for item and items a fixed grammatical form universally used? Yeah, I would say it's emblematic of something that we usually do in Python, which is if I have a list of objects or a collection of objects, the collection will be some plural noun like points. And then when I iterate over of that, I will iterate for singular noun in plural noun. So like for points in points, for item in items, for name in names. That kind of grammatical pattern is common for iteration. I am not quite sure what this particular question is asking. Okay, we've reached the end of the office hour. Yeah, for man in men, also fine. For person in people, yes, also fine. Okay, so I will be back tomorrow, and I will speak with you then. I hope you enjoy the rest of your day.